What's one of the methods you could use? I gave you 2 ways of attacking complex fractions. What's one of them?
Multiply by a common denominator.
Multiply by a common denominator of everything, right? Everything. Or what do? There was a second method. Do one side at a time. Do the numerator first, do the denominator second, clean them up, and then multiply by the reciprocal of the denominator. So either work on them separately or multiply by a common denominator. That was a good answer, Alex. So which one do you want to do on this one? Do you want to work on them separately, or do you want to multiply by a common denominator? I think separately would be better. So if you do that, you need a common denominator for these two. You look at this separately by itself right there. You do that one separately by itself. What's your common denominator going to be on this one? What's your LCD going to be? A squared, B squared, right. So it's going to end up being A squared over A squared, B squared minus B squared over A squared, B squared. What did I multiply in each case? I multiplied this one by what? Over B squared, which is just a form of what? 1, and this is? One thing you guys get in the habit of doing, please zoom in when you need to. So one thing you can do is if you need more space, you can infinitely zoom in on these things, right? So the point is you can zoom in and put in your little fraction as opposed to doing it off to the side. So anyway, we get this now. That's nice. And on the bottom, what's your LCD going to be right here? Your LCD here is going to be AB. So what are you going to end up with? A over AB minus B over?
Isn't that 1 over B and...
Yep, because now you multiply this by A over A, so you get A over AB, and you multiply this one by B over B, so you get B over AB.
Yeah, but don't those A over AB simplify into 1 over B?
No, because then you're back to where you started. The whole point is you need a common denominator so you can do what?
Subtract.
So you can actually subtract, exactly. So here we are right now. Can we now subtract on the bottom and top? Yep. So what do we end up with? A squared minus B squared all over A squared B squared all over A minus B over. So now you have single fractions. Now what can you do? You could do LCD, or you could just multiply by the reciprocal of the denominator. So you get A squared minus B squared over A squared B squared times what, Connor?
AB.
Yeah. And at this point, what's a good thing to do at this point?
Cross out by diagonally.
True, or you could do what? You could. So yeah, sure. If you notice something you can cancel, what can you cancel?
You can cancel here. You can cancel the A.
Yeah, the A goes away there, and that squared goes away. The B goes away, and that squared goes away. So just pause there. You get A squared minus B squared all over what? AB times 1 over. Are you done? No, because what can you do? Someone besides Connor, tell me, what can you do now? What should I do at this point? Hannah? Yeah, factor this. If you factor this, what does this whole thing become? And don't forget equal signs when you're doing math, everybody. I've seen some of you do videos where it's kind of like meander around the screen. Please put equal signs in. What does this factor into? A plus B times A minus B. Yeah, you have AB times 1 over A minus B. What cancels now? We are awake today. Yeah, that's right. So you get A plus B all over AB. Is there anything there that cancels? Please say no. What's the thing that messes up your urge to cancel things there? The plus sign. Because of that plus sign, can you cancel? No. If it was multiplication, it would be 1. Yeah, AB over AB would be 1, exactly. But it's not. It is plus. And what are the two methods you can use? You could either multiply by a common denominator, or you could work on things separately. Which one do you want to do? Which one?
Separate.
You said separate. What did you say? Separate? Okay, let's do separate. You know what? Okay, we could do it separately. How about we do? I want to do both methods in the example. Okay, so guess what? We're going to do this by the common denominator. Okay. On the top here, can someone just tell me what is your LCD on the top? 3. What's the LCD down here? 9y, right? 9y. So if these are the two LCDs, what's the LCD of both of those things? 9y. The LCD is 9y.
9 times, isn't it 27?
No,
because 3 goes into 9. You don't need 27. You could. 9 times 3y. 27y is a common denominator. But if we want the smallest one, does 9 divide into 9y? Yes. Does 3y divide into 9y? Yes.
Yeah.
What is basically what's the LCD of 9 and 3? 9. 9. What's the LCD of y and 1? Y. So you have y and 9, so it's 9y. Okay? Is everybody with me so far?
Yeah.
So what do we multiply the top and bottom by therefore?
9y.
We multiply the top and the bottom by, as Nick just said, 9y. And the reason we do this is because a lot of things will now cancel. We do 9y over 9. That's a cube, not a 9. 9y. Still kind of looks like a cube, but I'm saying those are 9s. What's 9y times y, Nick?
9y squared.
Correct. So let's just do this out. I'm not going to write the intermediary. So you end up 9y squared. And then you multiply, I'll write this one out, 9y times y minus 3 over 3, like this, all over. Mar, what's 9y times 4 over 9? What's 9y times 4 over 9? Mar, put the pen down. Put the pen down. Put it down. Put it down. Down. Look at the screen. Tell me what 9y times 4 over 9 equals. What cancels? What cancels? So you end up with, I'm just doing one of these out, plus 2 over 3y times 9y. Is there a little more simplification to do? Yeah. What happens here? This 3 cancels with this 9. What does it turn this 9 into? A 3. And this 3 cancels with this 9, turning it into 3. So what do you end up with? 9y squared minus what? 3 times what? Y minus 3 all over what? 4y plus what? Oh, look, the y's cancel as well, don't they? 4y plus what? 6. Do we have a complex fraction anymore? No, we don't have a complex fraction anymore. So are we done? No. There's probably something else that cancels or simplifies on this one. Probably. So what should we do to simplify? What's one thing we could do to the top? Well, let's do the opposite of distribute, actually. What's the opposite of distribute? Factor. What can we factor out of the top two terms? You can't pull out a 9, but what can you pull out? A 3. So what are you left with? 3y squared minus y minus 3. And what are you left with? What can you factor out of the bottom? What? So what is it? 2y plus what? Like this? So what do you suspect we're going to have to do at this point? Plus 3 all over. Oh, what did you say, Zoya? It's plus 3 because it's minus a minus right there. You see that? So what do you think we're going to have to do at this point? We should try to factor what part? We should try to factor this and see if it is nicely factorable. Let's see if it is. What is it going to have to break apart into? 3y and what? Is there any other way to break it apart? So I have a question. We haven't figured out what the factorization is, but what can you tell me? Will anything cancel? The only way to break up 3 is 3 and 1, correct? Do you agree with that?
Yeah.
But it's a 2y in the denominator. Look at the board. There's a 2y in the denominator, right? Is there a 2y anywhere on top? Is there a 2y anywhere on top? So therefore, is there anything we can do to factor and make this simpler? No. So guess what? You can stop right here. This would be fine. What's the point? It looks like it's more complicated. It looks like it's more complicated. Did we make a mistake, Hannah? You look perturbed.
I made a mistake.
Oh, okay.
I did it separate, but I got.
Did you get a clean answer?
Yeah.
Oh, so maybe we made a mistake. Let's check.
No, I don't think.
Okay, so what did I tell you yesterday? What was that first thing you had to do when you're dealing with a rational function equation? Domain. So can someone tell me what the domain of this function is? No, x such that x cannot be -6 or what? 1/2. It can't be. Saying the domain is 6 is the exact opposite. -6 is the opposite of what the domain is. The domain is all real numbers such that x can't be -6 or 1/2. Now you go on. Now what do you have to find? We did this on the board on Tuesday. What do you have to find? The LCD. Mar, what is the LCD of these two?
X plus 6 times 2x minus 1.
Yeah, sure. So what do you do once you find the LCD? What do you do once you find this wonderful LCD? Multiply everything by it, correct. And if you multiply everything by it, you end up with what? X minus 4 times what? 2x minus 1. And what's the other side going to equal? 2x plus 3 times what? X plus 6. Because there was a 2x minus 1 here, but what did that cancel with? these canceled, right? And what was over on the other side? The x plus 6, but what was in the denominator? That's why we did the multiplication, because now, when we just have this, are there any fractions involved? No. What do you have to do at this point? Okay, what are you confused about?
We said multiply each thing by the LCDs.
To solve that now, what's your only choice? What do you have to do? You have to, it's already factored, but it doesn't equal 0. What do you have to do at this point? You have to, someone said it over there, you have to multiply it out. So you have to multiply this out. Let's multiply this out. What does the left side become? Can someone read off the left side for me? Mar, what do you get?
2x squared
Yep.
minus x
Minus x, yep.
minus 8x
Yep.
plus 4.
Correct. Can someone read off the right-hand side for me? Connor.
2x squared plus 12x
Yep.
plus 3x
Plus.
18.
Nice. What are two things that immediately cancel right now? What's one thing that cancels?
Well,
What goes away?
2x squared.
Yeah, and is that awesome when you can get rid of the x squareds? Say hallelujah. Yeah, it's really nice because therefore you went from being a quadratic to being a linear. So what do you end up with? Negative 9x plus 14 equals what? 15x plus 18. Let's add 9x. Let's subtract 18. You get negative. Oop, it's drawing down there. Sorry. Negative 4. That gets rid of that. Equals what? 24x. Is that it? Right? So what does x equal? Negative 4 over what? Negative 4 over what?
Wait, how did you get 14?
How did I get 14? I don't know. I just canceled I turned a 4 into a 14. That was my mistake. Sorry. Okay. Is that better? Thank you for that catch there. That's helpful. So what do I subtract here? I subtract 18. I get negative what? Negative 14. And what's it going to equal on the other side? Ah, that's better, isn't it? So what is x going to be? Negative 14 over what? And that equals negative 7 over 12. So that's what we think the answer is. Now we found the domain at the beginning. Is this number part of the domain?
no.
Yes, it is. Please get this
Oh, yes.
tattooed onto your eyelids. You're remembering the domain in reverse, okay? I tried to come up with something graphic so you'd remember this. Is negative 7/12 part of the domain? Yes, it is. It is part of the domain. So is it a possible answer? Yeah. Theoretically, if we had some more time, what would you do at this point?
So,
You would check. You could check this. We're not going to do that at this point, but you could check it. You could check it.
But you said it is part of the domain?
Yes! Because read the domain out loud to me. Read the domain. Harry.
X.
Summer. X.
Is whatever. I don't know how you
X
say it.
such that X is not
such that
equal
X is
to
not negative 6 and 1.
or 1/2. So is negative 7/12 part of that domain? X is all numbers except for negative 6 1/2. We got an answer of negative 7/12. Is it part of the domain? Yeah. So don't worry. You spend so much time finding what the domain can't be that people tend to think that the domain is those numbers. Is the domain negative 6 1/2? No, the domain is everything else. Everything else. Okay, any other questions? I'll take responsibility. Look in the green here. Look what happened when we canceled. There's something that's missing that we totally left out between the two circled green parts. What did I miss? The y. Take a look at this. This thing right here, all of a sudden it should be there, right? Is that going to change things substantially? Yeah, it's going to change things substantially because there should be a y right there. And if there's a y right there, what can you also factor out? You could factor out the y, put it there, and that becomes 3y like this. You see that, everybody? So what's 3y minus y? So this is totally wrong, right? 2y. So what do you end up with? 3y times 2y plus 3 over 2 times 2y plus 3. Now, is this happy? Yeah. Is that what you got, Alex? And is that what you got, Hannah? Yeah. You got it. I was watching your video going, that is a lot better than what we wrote. What did we do wrong? All it was that one y. It happens. Okay, so let's get it, but it really isn't. This one gives you a function from the land of physics. Here's this function from the land of physics right here. Function from the land of physics. It talks about the focal length f of a lens, and it says in the formula p is the distance P is the distance from the object to the lens, and Q is the distance from the lens to the image. It says find Q if P is equal to 20 and F is equal to 10. So you have your formula, and it tells you that P is equal to 20 and F is equal to 10, and they want you to find Q. So what should you do first? Substitute. I love that. Substitute first before you do anything. So you have 1 over F is equal to 1 over what? 1 over 10. 10, you sure? Sorry. 1 over, okay, so we can start to go back even further. 1 over 10 is equal to 1 over what? 20 plus 1 over Q. So if you want to solve for Q, what should you do first, Mar?
We should find your domain.
Sure. So Q can't be what?
0.
0. Okay, so now what should we do? If we wanted to solve for Q, what should we do? Someone else tell me what we should do. What? We could, or we could do an LCD if we wanted to, or you subtract the 1 over 20. So you have 1 over 10 minus 1 over 20 is equal to 1 over Q. 7.5. This is 7.5, yes. 1 over 10 minus 1 over 20 is equal to 1 over Q. So if you want to do 1/10 minus 1/20, how do you do 1/10 minus 1/20? Common denominator. What's the common denominator going to be? 20. So you multiply by 2 over. So you get 2 over 20 minus 1 over, not 20. There's 20 equals 1 over Q. So what do we end up with? 1/20 equals 1 over Q. Can someone just look at that and tell me what Q is? Q has to be 20. If 1 over 20 equals 1 over Q, what does Q have to be? If you want to prove it, what can you do? What am I doing right now? You could cross multiply. If you cross multiply, what do you get? 20 is equal to Q. Is that exactly what we concluded? So this is a plug numbers in and solve. This is a plug numbers in and solve. Yes, Milo.
Scroll up, it says,
Yep.
so the beginning problem was like 1 over 10 equals 1 over 20. So how is 1 over 20 plus 1 over 20 equal?
It never had 1 over 20. It was 1 over 10 minus 1 over 20.
No, Milo's talking about plugging it back in.
No, that's the top one.
Because, okay, so you asking, we're going to check our answer, right? That's what you want to do? So 1/10 equals, is this true, is what you're asking. Well, let's look at this side. You can only do one at a time. If you have 1 over 20 plus 1 over 20, how many 20ths do you have? 2 over 20, and what's 2 over 20? And is that what it should be? Yes. Okay, so one thing, the simplest thing we can do is plug in all the values except one. Mar, put the pen down. Put it down. Put the pen down. Seriously. I'm going on record right now. Put the pen down. Watch this. Pay attention to this. You have access to the notes. Stop copying down everything I put on the board. One thing you can do is plug in values and then solve for a variable. One thing you can do is plug in values and then solve for a variable. Another thing you're going to have to do is solve for the variable first. You're going to have to solve for the variable first. So let's say I gave you this one right here. Let's say I gave you this one right here. And let's say I didn't have any values. I just wanted to isolate one of these. Which one do you want to isolate? F, P, or Q? F? Okay. If we want to isolate F, this is similar to our work with rational functions. You need to do a few things and not make simple mistakes. So try that for me by yourself right now. See if you can isolate F. See if you can isolate F. You're trying to get it to be F equals something. And there's going to be some P's in this side, and there's going to be some Q's. So try that on your own. What should I do first? Can someone tell me what I should do first? What should I do first? Okay, there's lots of different ways. Summer or Aubrey, you could do this. Can you tell me one way I should start this? What should I do first? Well, how about this? I'll ask you a question that I've asked you 100 times before. How do you add fractions? So what's the LCD of 1 over P and 1 over Q? PQ. So if I want to add these two things together, what do I multiply 1 over Q by? P over P, thank you. And what do I multiply 1 over P by? Q over Q. So I have 1 over F is equal to Q, and for some reason Q's are really hard for me today. Q over PQ plus what? P over. Do I now have a common denominator? Do I? Yeah. So now that I have a common denominator, what can I do with those two fractions? So I have 1 over F is equal to Q plus P over what? PQ. Now I have a fraction equals a fraction. So what can you do when you have a fraction equaling a fraction? Use your hands. What can you do? Use your hands. Cross multiply. You could cross multiply. So if you cross multiply, you end up with F times Q plus P equals what? 1 times PQ. Correct. What are we trying to isolate? F. So what should I divide both sides by, Summer? What? P. This is the F right there. So what should I divide both sides by? Q plus P. Divide by that. And what are you left with? F is equal to PQ over Q plus P. Have we isolated F? Yes, we have. The techniques we have used, kids, the techniques we have used, hold on a sec, multiply. So for example, kids, you have a fraction, everybody, stop talking. Take a look at that first. Can you erase the green on the projection for a second? I'm going to do some work right there. If you cross multiply, what do you end up with? I times what?
R
Plus
and R
lowercase r, yep, equals
and capital E.
N capital E. Have we gotten rid of all the fractions now? Have we gotten rid of all the fractions now? Yes. What are we trying to isolate? Which variable are we trying to isolate? N. So I'm going to circle this just so you see. How many N's do you see? 2. So what do we have to do at this point? There's something we have to do. You have to distribute. So if you do this, you get IR plus INR equals NE. Again, what are we trying to isolate? Trying to isolate N. If you want to isolate N, you need everything with N on one side and everything else on the other. So what should I subtract from both sides? INR. So you have IR. I'll show you use the same color here. You have IR equals NE minus what? INR. Again, there's what we're trying to isolate, correct? Everything else is just blah, right? Can someone tell me one word for what we should do now? One word. What should you do, Hannah?
Take N out.
You can take N out. So what? No, this is not easy. You have to make it N times what? Can someone tell me what's left? Not Hannah. When you take N out. E minus what? IR. Now, can you tell me what? One word. One word for what I do next. One word. Divide by what?
E minus IR.
Exactly. So you have IR over what? E minus IR is equal to? Have we isolated N? Yes. So this right here, kids, this takes practice. This takes practice. So I'm